Department, Weltech Rangarajan, Dr. Shakuntala R&D, Institute of Science and Technology, Chennai. So, definitely this webinar will give a lot of inputs, okay, and a lot of hopes for the students' avenue to understand the various innovative practices in the civil engineering. Sir, I know you are very busy schedule, and just I contacted Dr. Perumalji just 1 week ago before, and sir told his commitment, besides his pressing commitment, readily accepted our invitation, and he is ready to have the session with us. So, on the behalf of our management, on the behalf of our faculty, and the entire college, I welcome you, sir, to this webinar.
Thank you, sir.
I extend a very warm welcome to our fellow faculty members, my panelist, Dr. Alok Goyalji, Mr. Anupam Chaudhary, and all my faculty members. Also today, the faculty and staff members joining from other organizations also. I like to thank the faculties of CSMS Chhatrapati Shahu Kaldap Engineering Aurangabad, also Anantrao Power Government Pune. So I extend very warm welcome to Principal Dr. Ulla Shinde sir, Professor Sohail Ali, the HOD of CHMS, my friend Professor Naneshwar Mohite, Dr. Sunil Thakre, Sagar Gawande, and their colleagues also. So we open the platform in a broader way, as this particular topic is very, very interesting, and what are the various innovations possible in the field of civil engineering that today going to highlight Professor Perumal Pillai sir. Sir having a very vast experience in all the academic, administrative, and also the industry. Sir having the vast experience in the academic area, particularly in research in the various organizations, and hope this your experience definitely useful for the student. Just for the other participants also joining here, so I want to say that we are Meerut Institute of Engineering and Technology, we call it MIT Meerut. This college established in the year 1997, and this is one among the top 10 engineering college in Uttar Pradesh, which is affiliated to Dr. APJ Abdul Kalam, Technical University, Lucknow. Of course, is approved by AICTE New Delhi, and our institution is accredited by NBA as well as NAC. Our MIT has merged our leading group of providing the technical education to the student. Presently, our MIT offering 14 UG programs, 13 in engineering and 1 in pharmacy. Also, MIT offers 8 PG programs, 4 in engineering and technology, 2 in pharmacy, MCA and MBA. So, are more than 4,500 students currently studying in this MIT campus. So, we are a very beautiful campus. So, I welcome on the behalf of our own base, on the behalf of management, to visit our institution whenever you feel free. And definitely, Dr. Perumal Pillai ji, you have to visit our institution when this everything pandemic situation get over. Let us hope this coming 2021 with a lot of hopes, not only academic area, okay, other also area research and development, and particularly all innovations will possible in the 2021. So with these few words, once again I extend very warm and cordial welcome for the students, guest today's speaker, Dr. E.J. Perumal Pillai. My dear students, you know the innovation possible in all sectors. Sir is going to highlight some of the innovation what is possible in civil engineering field. As you know, the civil engineering field is very vast. Lot of innovations happening in the construction side, in the case of water supply, geotechnical side, okay, hydraulic side. So day by day innovations are there. Nowadays the technology is changing, and with this changing technological world, we have to upgrade ourselves. And I think upgrading ourselves really very useful. Upgrade yourself, academically also, and enhance your knowledge in all sort of fields. So hope that today this webinar give lot of inputs, and our sites will be open, and we'll say, so these are the more avenues are there, how to work together to achieve the technical excellence, and what are the innovations possible in the field of civil engineering. So with these few words, once again, I extend very warm and cordial welcome to everyone present over here, all the participants from MIT, participants from Chhatrapati Shahu College of Aurangabad, Dr. Andhra Paul College Pune, all fellow faculty members, my dear friends, everybody, and particularly most and cordial welcome to our distinguished speaker of the day, Dr. E.B. Perumal Pillai sir. So, most welcome everybody once again. So with these few notes, I extend warm welcome to everyone. Now I request my colleagues, Associate Professor Dr. Alok Goyalji, to introduce our speaker of the day. Over to Dr. Alok Goyal.
Director, HRDC, Engineering. Earlier served as Institute of Technology. Established by Director of Government of University of Technology, Madurai. Third runner world as the principal of Engineering and Technology Chennai. He has over nearly 36 years of experience.
Sorry, your mic is not, you just unmute yourself. Okay. Continue. It's not audible. Now it's okay. Okay, good. Correct.
Sorry for the interruption. He has over nearly 36 years of rich experience in the academic arena, along with 1 year of industrial experience in Tamil Nadu Public Works Department. He started his illustrious career at the Coimbatore Institute of Technology as a lecturer and moved to be the professor in the Department of Civil Engineering. He is actively involved in the MBA accreditation, AICTE, UGC, PhD, CSIR and IEI projects, and served as a member of governing and academic council of leading institutions. He also served as the director, School of Engineering and Technology at Tagum University, Coimbatore. He has served in the countries like Ethiopia and Sultanate of Oman. In recognition of his entire project in the field of education, he was awarded the Anna University National Award for Outstanding Faculty from IST New Delhi. In year 2009, he was also awarded the Eminent Engineer of the Year 2010-11 by the Institution of Engineers, Calcutta Madurai Research Center. He has also been conferred with the Best Academic Administrator Award by the Association of Scientists, Developers and Faculty, that is PSDF. He has received Excellence in Human Resource Development Training Award by the Construction Industry Council. He has got Best Research Guide Award from the Society for Educational Internship Development, that is SEED. He has been beloved with Lifetime Achievement in Civil Engineering of Research Award. Strong commitment towards research is reflected in his of important publication and more than 140 national and international publications. He has participated and presented a paper in the 23rd World Housing Congress held at Singapore in 1997. His area of research includes the design of quake resistant structures that withstand in the physical festivals. He is actively involved in the various research activities involving cutting-edge technology a group of international conferences who have studied including international conference on innovative and smart structural systems for at INFILTRATED 22 Institute of Technology, 22 January 2006. MARTIAN PG is instrumental in conducting various conferences, symposia, seminars, workshops, and faculty development programs at international and national level. He is one behind motivating the faculty members to obtain grants from various government and non-government funding agencies such as CIPT, IST, BRMS, etc. Conduct various at Karpagam University, Kerala. He served as Director, School of Engineering and Technology, presently as the Director, Human Resource Development Center at Caltech University. He has continuously been organizing faculty orientation program, faculty motivation program, and faculty development programs also. He has guided 12 PhD scholars in civil engineering in University, Chennai, and Karpagam University, Kerala. He was a distinguished member of the National Executive Council member of the Society of Technical Education, that is ISTE, for 8 years, and member of various professional bodies such as American Society of
Arun sir, can you hear it?
ACI, Institution of Engineers in India, he believes and practices positive approach and attitude staying around. Sure, he is a pioneer in the promoting engineering education and education. We welcome you, sir. Over to you.
Dr. Alok, there was no audio. There is no audio here.
Hello?
Yeah, sir, it's fine.
Voice?
Yeah, yours is fine. Yours is fine, sir.
Oh, Dr. Gwal, voice was not clear. Huh? Okay. So, thank you, Dr. Pillai.
Yes, sir.
Dr. Pillai has a very vast experience, more than 36 years of rich experience in academic area, along 1 year industrial area in Tamil Nadu Public School Department, and so has acted as the first registrar in the old Anna University of Technology, Madurai, which was established Act of Government Tamil Nadu after that. And sir obviously published more research papers, more projects also, and lot of awards he got, and more than 140 national international publications he have, and more than around 12 PhD students guided very successfully. So, sir, profile is very vast, and with this short profile, now I like to invite our today's resource person and speaker of the day, my good friend Dr. E.B. Peruvan Pillai, to take over the dais. So the dais is yours.
Thank you very much, sir, for the nice introduction. So, thank you very much, Dr. Alok Goyal, for the introduction also. So, good afternoon to all of you. So, am I audible, sir?
Yes, sir.
Very good audible.
Absolutely fine.
Very good audible.
Yeah. So, first of all, let me express my hearty thanks to Dr. Arun Navi Parwate and his management for inviting me for this webinar, online webinar. And really, I'm very happy to participate and share some aspects of the developments or recent innovations in civil engineering. So let me start with a quote. What you do today can change your tomorrow. Very much applicable to civil engineers. So these are the presentation outline. So initially, with some introduction, let me discuss the developments with respect to construction materials, especially with respect to cement, concrete, and smart and green buildings. What are the advancements in techniques, construction techniques and management, and what are the softwares available, and developments in technologies. Finally, let me share the concluding remarks. As all of you may be aware, civil engineering is the mother of all branches of engineering. So without the presence of civil engineers, the world cannot exist. We are responsible, the civil engineers are responsible for the planning, development, construction, maintenance of all the infrastructures in the country. So as many of you may be aware, these are the broad domains: structural and solid mechanics, concrete technology, wastewater treatment, etc., etc. But mostly we'll be discussing the developments with respect to concrete technology and construction management. Lot of changes are taking place almost in all the fields of engineering. Especially the rate of change is very fast when we consider the branches like computer science and engineering, information technology, etc. So the developments which have taken place last year may become obsolete this year. So the engineers in that field, regularly they have to update their knowledge with respect to the recent developments. And civil engineering is no exception. So in civil engineering also, lot of change. Change is the only thing that never changes, people say. So in civil engineering also, lot of changes are taking place, as I mentioned, with respect to materials, with respect to construction technique, and with respect to other aspects also, like construction management and so on. So if you recollect, in 1960s, we started with ordinary Portland cement. Then, mostly people used to call it as OPC. Then in 90s, we started calling the cement with respect to their grades: 33 grade, 43 grade, and 53 grade OPC. In 95, blended cement with special cement, we started getting that one. And many admixtures are there, both chemical admixtures and pozzolanic admixtures, to impart one or more of desirable quality. And depending upon the requirement, we can add the admixtures. But now the multi-blended cements are available in the market. The manufacturers themselves will add the required admixtures to impart the desirable qualities. So now that with respect to cement, we have reached a stage in which we can get or we can buy multi-blended cements with powder hyperplasticizers, silica fumes, etc. Then with respect to fine aggregate, sand is the most common one we use, and flowing streams and rivers or pits or quarries are the main sources for sand. And many state governments, they have banned the use of river sand for construction purposes. So now that we are, going for M sand, manufactured sand or artificial sand, so the ideal sand will be restricted quantum of chloride, sulfate, silt, clay, etc. So we cannot use the sea sand available near the seashore because of the contents of the chemicals, etc. So present trend is manufactured sand. So manufactured in crushers to the same grading as natural zone 2 or 3, depending upon the requirement. So when we consider the aggregates, coarse aggregates, normally till recently people believed that preferred maximum size of aggregate for concrete works is 20 mm aggregates. And there is a general belief that strength is higher with concept of higher size aggregates. In reality, it is not true. So the change in trend is demand for liquid concrete, demand for high performance concrete, trend towards smaller aggregates to achieve the above. That is, basic studies and fracture mechanics studies have indicated that smaller size aggregates to be preferable. So uniform grading of aggregates should be there in order to get the best concrete out of that one. Then, of course, the recycling of aggregates, earlier concept, again, from natural sources, you have to obtain the aggregates, but now environmentally friendly procedures, recycling of debris, oil, and sewage waste, conservation of natural resources. We can just conserve the natural sources by opting for the recycling of aggregates. Coming to water, till 1975, best source for water is it was a natural source, either river or other water sources. But what is the ideal mixing water? Normally, people say that potable water should be used for mixing of concrete and curing, etc. But in reality, nowadays, most of the potable waters are proved to be unfit for mixing. The condition is that it should the water we have chosen should satisfy the relevant standard codal provisions. So today's best mixing water is processed water satisfying the relevant BIS standards. Coming to the reinforced bars, again in 1967 we used to use MS plain bars of grade FE 250. Again, further development, twisted deformed bars of grade FE 415 came into existence, and recent developments, again, in addition to the above, FE 500 grade steel also we started using. And corrosion is the main problem in reinforcement concrete. In order to contain corrosion, we started using stainless steel bars also, of course with a limited application. Then now that recent development is FRP, reinforcing bars, and development of cladded reinforcing bars. So fiber reinforced polymer reinforcement bars, of course, we'll be discussing a little more detail later on. Then a lot of admixtures are there to impart one or more of the desirable qualities, and the purpose all of you know very well. Let me not repeat those things. Then with respect to the admixtures, earlier till 1980, only air entraining agents from natural vegetation used to be used in concreting. Again, we started using different types of admixtures, especially plasticizers and super plasticizers are widely used one, and the base are also given there, and recent developments also carboxylate ether-based hyperplasticizers, and many more are available. Then coming to the ingredients, earlier normally concrete means cement, fine aggregate, coarse aggregate, and water. In 1960s, we used to have only 4 ingredients. In 1980, with the addition of plasticizer, the constituent materials, the number of constituent materials became 5. Then later on, with inclusion of silica fume, 6. Again, fly ash or GGBS, it became 7, and so on. Again, we started using blended cement and multi-blended cement, and finally, nowadays, multi-blended cement with rock fractions, processed water, and we can add latex solution to impart ductility. So recent days, the number of ingredients can be either 3 or 4, depending upon whether we are using latex solution or not. So latex solution will improve the ductility properties. Cement is a brittle, or concrete is a brittle material. So in places, especially in earthquake-prone zones, the ductility is a very, very important property. So in order to introduce ductility, you can use latex solution. Lot of research work is going on in use of latex solution to improve the ductility of the concrete. So regarding the grade of concrete also, earlier we used M15 to M45. Now that higher strength concrete we are using, so M30, 60, M80, or even we are going for up to M100 also. Throughout the world, people are using up to M120 also. Still, a lot of research work is going on in order to produce the higher grade of concrete up to M200. And with the availability of all the types of plasticizers and admixtures, it is time is not quite far off that definitely will be able to achieve higher strength concrete or higher grade concrete. So recent advancements, cement. Of course, I'm not going to spend much time on this one. So all of you are familiar with all these things. So OPC, PPC, rapid hardening cement, extra rapid hardening cement, quick setting cement, low heat cement, sulfate resisting, potent slag cement, high alumina, different types of cements. Depending upon the necessity, we can make use of all these things. So coming to this one, I mean, advancements in concrete. These are all very common, even though some of them are developments, like self-compacting concrete, self-curing concrete. Other concretes are very commonly available, or people are very commonly using these things. In fact, our normal nowadays the procedure for preparing concrete is that proportioning or mixed design. After that, proportioning the materials, mixing, transportation, placing, compaction, and curing. These are the various steps involved in manufacture of concrete. Maybe after 1 or 2 generations, the future generation will be studying a different procedure for preparation of concrete, especially with the availability of many admixtures. We will be opting for self-compacting concrete, in which case the need for vibration or compaction will be absent. Similarly, many chemicals are available. Thereby, we can get rid of the regular procedure for curing of concrete. So, self-curing compounds are available, using which no need for external curing. So, these 2 steps, compaction and curing, will be absent in the methods of preparation of concrete when the future generation studies the method. Then comes of course, fiber reinforced concrete is familiar to all of you. Normally, cement or concrete is very strong in compression, weak in tension. In order to introduce tensile load carrying capacity, we introduce the reinforcement. But in the case of shell structures, providing the reinforcement may be difficult. In such cases, we opt for fibers. So, so fiber reinforced concrete we have. So the updated version of fiber reinforced concrete is slurry infiltrated fiber concrete. In short, it is known as SIFCON, SIFCON. So random placement of steel fibers in the mold to form a fiber bed. So in the mold, the fibers will be placed in a random manner. Then cement slurry or rich flowing cement mortar will be poured onto the fiber bed and vibrated to ensure that the cement mold or cement slurry reaches all the nook and corner of the mold. So curing is almost identical to other concretes. Only thing here, the fiber volume in FRC, normally in fiber reinforced concrete, it is 1 to 2%, whereas in SIFCON, it is 6 to 15%. Sometimes it may go up to 20% also. Again, another modified form of SIFCON is SIMCON, slurry infiltrated matte concrete. In SIFCON, we place the fibers in a random manner, whereas in SIMCON, we provide or we place the mat or fibers in the form of a mat in a layered fashion. So these SIFCON, etc. are used where the structures may be subjected to blast loading, dynamic loading, etc., or even earthquake-prone zones where the ductility should be there actually, or especially the beam column joints are critical points where in the event of an earthquake, the damages may be caused due to failure of beam column joints. So the SIFCON or SIMCON can be made use of in beam column joints in buildings constructed in earthquake-prone zones. Then, of course, the compact reinforced composite CRC, which is very strong and brittle cementitious matrix, toughened with high concentration of fine steel fibers. So when we use more fibers, and the resulting one is called as compact, and here it will be pressed actually, not conventional vibration or this thing. So again, the behavior, mechanical behavior will be more or less like that of structural steel, but when we opt for steel construction, the cost is much more. So when we opt for CRC, probably cost can be reduced, but the strength will be almost equivalent to that of a steel structure. So again, the flexibility or the concrete is a brittle material. So we can make the concrete as a bendable one. Again, a lot of research work is going on in various countries to make the concrete a ductile or bendable one by using the apt admixtures. Then of course, normally, in concrete structures, light cannot be transmitted. But again, research by Hungarian architect Aron has proved that we can introduce this property also, light transmitting property also for concrete, especially in places where privacy is not important, but the lighting is important. We can opt for light transmitting concrete. Pervious concrete, normally, in order to avoid or prevent corrosion, we have to make the concrete as dense as possible. So we have to minimize the porosity of concrete. But in certain places, especially in places like pavements, when we use concrete, it should be porous so that the whatever rainwater is collected, it should seep through in order to maintain the groundwater table at a higher elevation or higher level. So in such cases, the pervious concrete will be very much useful. Then, now a lot of research work is going on the suitability of materials available in moon to use it as a construction material. So sometimes, tomorrow people may start traveling regularly, traveling to moon. So if you want to stay there for a short period, we have to make use of the materials available in moon for construction purposes. So when we make use of the materials available, or sometimes, modeled one for construction purpose, the resulting concrete is known as lunar concrete. Ductile concrete, as it is more or less like bendable concrete. Earlier we already discussed it. So when we introduce ductility property, probably it will be ductile concrete or this one. Similar to lunar concrete, this is Martian. So again, the growing interest in Mars colonization since NASA's robotic Curiosity rover landed in the planet. So many people may be interested in traveling to Mars in future, or maybe again suitability of the materials available in Mars for construction purposes. That type of concrete is known as Martian concrete. Again, smart concrete, many times termed as conductive concrete. When carbon fibers are introduced while preparing the concrete, the electrical resistance will get increased, thereby the concrete will behave, or we can just monitor the stress level, strain level, etc. So that type of concrete is known as smart concrete. Applications in different, especially the highways, where by sitting in front of our system, we'll be able to measure the weight of the vehicle, speed of the vehicle, and so on. Then, of course, the other popular concrete is bacterial concrete. The ability of living organisms to form minerals has led to development of bacterial concrete. Bacteria will be introduced, especially for repair and rehabilitation work. This type of concrete can be made use of. FRP bars, as I mentioned earlier, corrosion is the major problem in concrete. So even though other methods are there using CRS, corrosion resistant steel, and using the different types of coatings on concrete surface, we can minimize the corrosion problem. But another option is that fiber reinforced polymer or plastic reinforcing bars are available in different colors, and the weight is almost 25% lesser than the weight of the steel, and easier fabrication, installation, and electrically and thermally non-conductive, and invulnerable to chemical corrosion. And maybe initially the cost of FRP bars may be slightly more than that of the reinforcing, conventional tar steel or MS bars. But when you use it in a large scale, and if you consider the life cycle cost, initial cost plus maintenance cost, definitely this may be cheaper than use of the other one. Then polymer concrete composites, different types of polymers are there, polymer concrete are there, polymer impregnated concrete, polymer concrete, PP, polymer Portland cement concrete, and so on. Waterproof concrete. So the use of air entrained concrete reduces the permeability. So you can just get a waterproof concrete using the water reducing agents and so on. Low roller compacted concrete. So it is sometimes called as it is sometimes called as rollcrete, which is a low cement content stiff concrete placed using techniques borrowed from earth moving or paving work. So it will not be compacted like our conventional method. So it will be compacted using heavy rollers. So the resulting concrete will, with the concrete mix achieves a high density and cues over time into strong monolithic block. So especially for concrete pavement where the durability should be more, we can make use of a roller compacted concrete. Of course, when we make use of the recycled glass as aggregate, the resulting concrete is known as glass concrete, especially from aesthetic point of view, that type of concrete can be used. Asphalt concrete, here the cement will be replaced by form of concrete as well as the bituminous materials as the binder. So rapid strength concrete, where the result or the strength achievement can be obtained within shortest period. And we know very well the advantages of rapid strength concrete. Decorative concrete. So normally concrete means conventionally we have standard color, appearance, etc. So in order to improve the appearance, we can have or we can opt for what are known as decorative concretes. So used mainly to increase the or enhance the aesthetic appearance. And of course, a variety of materials can be made use of. Just one form of decorative concrete is stamped concrete. You can say, even though the pictures show the looks like tiles, but really they are the floors or the pavements are prepared out of the stamped concrete. Self-healing concrete, of course, another name for bacterial concrete. We already discussed various different types of bacteria are there. So mainly for carrying out repair work, we can make use of bacterial concrete. Again, throughout the world, a lot of research work is going on, and also people are making use of bacterial concrete for repair and rehabilitation works. Apart from the developments in concrete, let us discuss the developments which have taken place or the innovations which have taken place with respect to the other materials also, like timber, etc. Mass timber. So normally when we think of multi-story buildings, always concrete will come to our mind. But timber can also be used for construction of multi-story or tall buildings. Of course, the sulfate will be less, and it has its own advantages and disadvantages. So in the case mass timber, that is solid wood will be panelized and laminated for increased strength and other useful properties. Even it can help tall wood buildings to appear in the cities across again. And wood, which is originally high performance material, is 100% natural and renewable. So unlike concrete structures, you can just always dismantle or reuse the wood removed from a particular building if necessary. And again, concrete, while preparing concrete, that affects the environment, conservation of energy, especially when we opt for green technologies or green buildings. Naturally, instead of concrete, we can opt for timber, provided timber is available in plenty. Air cleaning bricks, which are also known as the breathing bricks. So the air outside the structure is directed into rectangular inlet ports with the help of faceted surface of the brick. The air that comes into the system is spined by cyclone filter winnowing out particles. So you can just see the arrangement here. So double wall with the window operable vents. So air will be passed through this one. So when the air inside, air reaches the inside portion of the building, automatically you will have the cooling effect, you can say. Mainly, this type of bricks is optimal for 1 or 2-story buildings or structures where the air quality is very poor, especially where pollution is more. This type of bricks can be used for construction purposes. It has its own advantages. Again, cooling bricks, passive cooling ceramics. Here again, the bricks will have a lot of pores through which more or less like air conditioning. So in the construction stage itself, we can make use of this type of bricks so that we will have cooling effect inside the house without the consumption of electricity. That's a major advantage. Wool bricks, again, researchers in Spain and Scotland, they have been experimenting with modern forms of unfired clay bricks with dubbed wools actually. So here again, zero carbon product that can be sourced using local materials. So very strong as compared to the unfired stabilized earth blocks or bricks, and it can be labeled as a zero carbon brick. Environmentally friendly brick, you can say. So programmable cement. Scientists at Rice University, Texas, they have decoded the kinetic properties of cement and developed a way to program the microscopic semi-crystalline particles within. So this process turns the particles from disordered clumps into regimented cubes, spheres, and other forms. So this will make the concrete less porous and more durable. So this technique may lead to stronger structures that require less concrete. Again, self-healing material, we already discussed. 3D printing bioplastic. So 3D printing is a formidable tool to introduce robotization into construction and other kinds of innovations. So we can just, the components can be prepared out of this 3D printing technology. So graphene is another material which is gradually finding place in construction industry. It has its own, especially where the nanomaterials are to be used, we can make use of the graphene. Similarly, aerographite is another material which is coming into existence. Aluminum foam. So especially in facades, wall cladding, ceiling tiles, etc., this type of material can be used. Everywhere in almost all the fields of engineering, nanomaterials or nanotechnology is finding its place. Again, in civil also, we can make use of this nanotechnology or nanomaterials for construction purposes. So this is one application. Again, biochar is a carbon negative construction where it is required. We can make use of this one. Low thermal conductivity is one important property of biochar. So nanomaterials in construction. So different forms we can make use of nano powder form or coating form. We can make use of this one, especially when we make use of nanomaterials in concrete. Automatically, the concrete will become dense, or the compaction will be better, and thereby minimizing the porosity, and we'll be able to get dense concrete. Automatically, the corrosion will be minimized or can be avoided actually. Nano cement and nano concrete, a lot of research work is going on, and in the field, again, slowly it is finding its place. Actually. The concept of greenhouse effect or green buildings. So as far as possible, without the external, artificial arrangements, we should be able to get a cooling effect, or we have to minimize the pollution to the environment. So green homes and buildings are increasingly becoming in vogue in neighborhoods and the corporate sectors around the world. So it can save energy and maintenance cost in the homes and offices. And also we can minimize the pollution we are causing to the society. Smart and energy buildings and energy efficient constructions. Smart buildings, automated buildings, or intelligent buildings. So the building should behave depending upon the situation. So buildings with automated systems or wireless technologies, embedded system. So even the health monitoring of structures. So not only buildings, even the structures like bridges, etc., where by sitting in front of a system, we will be able to find or identify whether a particular part of the building or a component of the building is subjected to more levels of stresses, and so on. Of course, the need for smart construction, we know very well that the developments taking place is also must. And how can we make use of the smart construction? Benefits of smart construction: better quality, whole life building cost, designed for well-being, boost flexibility, deliver environmentally friendly behavior, and health and safety. All these things are there. And sustainable constructions, especially the green building constructions. So all these are the features of sustainable construction. So sustainability. So we have to preserve the natural resources for the future generation without compromising the quality of the present needs. So we have to make use of, we should not exploit the natural resources. So when we opt for sustainable constructions, definitely the future generations will also be happy to live in this planet Earth. Then coming to the construction techniques and construction management, what are the developments which have taken place? So modern construction techniques are methods that are developed in construction industry with proper planning and design, so that each project reduces the construction time, cost, and maintenance, overall sustainability. So most famous and highly applied methods of modern construction are precast flat panel system, 3D volumetric modules, flat slab construction, precast cladding panels, twin wall technology, precast concrete foundation, etc. Of course, the flat slab construction I have omitted since it's available in regular textbooks. Flat slab construction I have omitted here. So precast flat panel system, the components can be manufactured in the industry and it can be brought to the site and we can just assemble this one. There are some advantages as well as disadvantages. The construction time can be minimized, and the quality control will be better when we fabricate the panels in the industry, and we need not bother. But the connections should be proper, and the panels are to be standardized. There are dimensions are to be standardized if you want to opt for precast flat panel systems. Some pictures related to that one. The various components, wall panels, parapet beams, spandrel, etc., can be fabricated in the industry and factory. It can be brought to the site and it can be assembled, you can say. So again, later on, if you want to dismantle the structure, it will be very easy as compared to our conventional concrete structures. Again, instead of panel members, we can fabricate 3D volumetric modules also, again, which can be fabricated in the industry, which can be brought to the site and the construction can be carried out. Again, precast cladding panels, the panels can be, just fixed. The cladding system is, is the insulation of material over another that finally acts as a skin or a layer, wall panel, like this one. So there will be better aesthetics and infiltration of the weather elements will not be there. And since they are fabricated in the industry, there will be better quality control. So no involvement of human labors in the, while like our cast institute concrete structures. So no kind of waterproof condition. So naturally the durability will be better. Durability, and when we produce in mass scale, there will be, it will lead to economy also, speed in construction, quality of construction will be better. Appearance will also be better. So twin wall technology. So here again, so you can just see the twin wall technology. So where the walls units are placed on site and the twin units are propped temporarily. The wall units are later joined by means of reinforcement. Again, the foundation can be prefabricated and brought to the site. And here again, similar to the other type of construction, prefabricated construction, here also, speed of construction is more, quality control will be better, and so on. Then coming to the developments in software. So, earlier even construction of 3-story or 5-story building itself will be difficult, before the invention of the software. So the manual methods, moment distribution method or other types of methods we use to analyze the frames. But now with the availability of different types of software, whether it is drawing the buildings, plan and the project planning, etc., or any area in almost all the domains, the softwares are available. And with the availability of such softwares, now that for any civil engineer, sky is the limit for going for tall buildings or skyscrapers. So with respect to drafting or drawing, we have AutoCAD and SketchUp. For project planning and project management, Primavera, Microsoft Project are available. 3D modeling of structure or architecture, Autodesk 3D Max, Autodesk Maya, AutoCAD Civil 3D are available. For geotechnical work also, we have these softwares available, GeoStudio, Geo5, and etc. Praxis, many people are using these softwares also. Again, for road designing analysis, MX Road, Bentley Road Network are available. Again, many of you may be aware of all these structural analysis and design software, StatPro, SAP 2000, ETABS, Revit Architecture, Midas Gen, SAFE, Abacus, etc. Again, for cost estimation, we have the Candy software, NetSuite, SAP, ERP, Core Finance, and risk analysis at risk are available. So with the availability of all these softwares, the difficulty we face for construction of multi-story buildings are minimized, and we can have better quality and accurate design also. The analysis, even if it is 100-story building, without spending much time, only thing you have to feed the data in the analysis software. Within no time, we can get the results. And especially for repetitive calculations, with some changes in the parameters, we can get designs for new structures also at an earlier date, and better quality control will also be there. Then applications of technologies. Some of the latest technologies in the construction industry are, all of you are familiar with the Internet of Things. So big data, building information modeling, BIM, is becoming very popular nowadays, even though in our day-to-day construction activities we are not introducing, but the time is not far off that we will start using. But in some other countries, it is very common use of BIM and augmented reality, virtual reality, blockchain, laser scanning, artificial intelligence, off-site manufacture, automation, etc. So quickly, we will just browse all these terms, terminologies. The term big data refers to an industrial revolution brought about by the use of vast amounts of data characterized by volume, variety, and velocity for business improvement, cost optimization, and prediction of revenue. So especially in construction of buildings, cost optimization is important, and the prediction of revenue is also important. The third function has been found to be applicable to the construction industry to improve the cost effectiveness. Cost reduction is the final outcome of the comprehensive information on cost effectiveness produced by big data, directed techniques, and tools. Building information modeling. BIM offers numerous precise and practical data to the construction industry, from an improved computer-aided drawing CAD model to the involvement of project stakeholders, in a multidisciplinary working environment. BIM presents considerable potential for coordination, collaboration, and integration, along with the improvements in information flow and data processing that reach beyond the capacity of traditional construction methods. The leading practices of BIM are planning and scheduling, constructability assessment, 3D model visualization, clash detection, measurement estimation, site management, safety management, and operation management. One of our Weltech University has signed MOU with many foreign universities, and recently, last year, one of our final year students, he went for his internship to Taiwan, where he underwent training in this BIM model, and with his knowledge in BIM, he could get a job there. Apart from that, he got offer from an education institute also for MS program. So he got 2 offers because of his knowledge about BIM. So it's a new avenue for many of the budding civil engineers. Then comes to augmented reality. So the captured images can be manipulated in the same way as they can in reality. So augmented reality originated from virtual reality, which partially creates an environment wherein the operability of an object can be sensed and practiced in real time to improve the human understanding of it. As the high quality visualization of details is very effective for reducing the complexity of information, it is claimed that the augmented reality techniques accords with the big data objectives to generate information for better decision making and a better understanding. For example, AR is capable of being paired with a BIM to enable designers to apply more maintainable and sustainable principles to their designs. Then comes virtual reality. So users can experience a real working environment before project completion. During the planning stage itself, we can just 3D modeling, and we can show the clients how the building completed will be looking like, and walk through. You can just take them to the hall, to the other rooms, etc., as if they physically they are moving from room to room like that. So that techniques are also available nowadays. Then blockchain techniques through which database of records, transactions, or digital activities are recorded and distributed among the stakeholders. Once entered, the data can never be changed or removed. So the 4 characteristics are: it is public, not owned by anybody; it is decentral, not stored in one single, more or less like our cloud computing, you can say; constantly synchronized to keep the transactions up to date; secured by cryptography, so that it becomes hacker proof; smart construction relies on BIM for manipulating information flow, data flow, and management flow, which the blockchain can address. Then, of course, laser scanning. Laser scanning is a technique by which the actual accurate data from an as-built situation are retrieved by scanning the work's progress or status. The data can then be used to evaluate the quantities of work and to report progress or for decision-making process. Even the laser, the principle of laser is already finding it even in the case of total station. So we are making use of this technology nowadays. Even survey, for measuring the distances, we use laser-based instruments to measure the distances, more length or breadth, height, etc., more accurately. And especially in places where we cannot have access, this type of instruments will be very much useful. Artificial intelligence techniques. AIs are techniques whereby human perceptions can be transferred into machines, allowing them to perform the way humans are supposed to behave in a complicated situation. So artificial intelligence, it has become, long back it has come into existence, but nowadays it is finding its application in civil engineering field also. Then, of course, off-site manufacture. So OSM is a technique offering a combination of prefabricated components and on-site activities. The components are either erected to shape a constructed object or attached to in situ built components. In fact, the offsite components are produced in a controlled manufacturing environment and then transported and positioned onto a construction site. Then, of course, automation everywhere it is taking place, even in construction industry also, for construction of walls or anything. So automation refers to a technique by which the procedure or a cycle of process is carried out with minimal human involvement, even whether it is for construction of walls or even plastering of the walls. We can automate everything. So the technique makes industries more efficient, more effective by applying softwares as well as hardwares to complete the task automatically. Though this highly beneficial technique, equipment, machinery, and process are operated via controlling systems in complex situations. However, sometimes a controlling system fails as a consequence of human-related errors, and any potential benefit is transformed into a loss or even a disaster. So we have to be very cautious while automating or making the system an automated one. The automation not only has been observed to optimize the construction site productivity, but is also capable of promoting the mass production of prefabricated construction components in factories. In certain areas, where the environment is not conducive, or so chemical prone areas where chemical smokes are there, or wet this thing. So in certain cases where human construction cannot be carried out, or it may be difficult for us to carry out or involve the human being for construction work, this techniques will be very much useful. So faster and the better quality control will be there. Actually, there will not be any compromise, especially when human labors, sometimes, when uneducated laborers are getting involved in, so this type of construction techniques, construction of walls, or plastering work, etc. The quality or the finishing may not be perfect, but whereas when it is automated, the finishing will be almost 100% perfect. So far we have discussed what are the innovations which have taken place with respect to various materials, construction materials, especially concrete, other types of materials, etc. The construction techniques, and of course construction management, and the softwares available, etc. So the search for new materials and new and innovative construction technologies is a continuous process. As long as the inquisitiveness of man exists, the search will continue unrelented forever. It is up to the civil engineer to make use of the developments to create structural marvels. One thing all of us should understand, that people say that if at all a doctor commits a mistake, he can kill only one person. Whereas if a civil engineer makes a mistake, either in planning or construction or maintenance, etc., then the cost will be damaging, or the damage we will be causing will be much more, actually, which can never be compensated, actually. So there are so many case studies are there where a small mistake, either in design or construction, has caused havoc, actually, causing, most regularly we are seeing through the newspapers or the news channels that some buildings are collapsing during construction stage itself. And the reasons may be plenty, the repair and rehabilitation work itself, the topic itself is a big subject, where the quality of materials, quality of construction plays a vital role, and the perfection in design, that is also very, very important. So we, the civil engineers, should understand our social responsibility. So we are responsible for perfect planning of the structures, constructing and maintaining, and everything we have to consider, so that we will be able to have a safe and durable, we will be able to have a safe and durable structures which will make the society a safer one, actually. So if only we can construct buildings like this, definitely it will make the world a perfect one. So once again, I take this opportunity to thank Dr. Arun and his management for inviting me for this session. And I take this opportunity to thank all the audience for their patient listening. Thank you very much. May God bless you.
Thank you very much, sir, for your nice topic, particularly covering the construction, nanotechnology, what innovations are going on, and how the civil engineering can use the best of this. Hope this lecture will utilize for all our students, community. I hope there is no any queries from the student or question in the chat box. So thank you, sir. With these words,
yes, sir.
I invite our panelist, Mr. Anupeksha Chaudhary, to propose the vote of thanks. Over to Anupeksha. Just before that, one question is there. Just Anupeksha. One student asking why the lime is not used instead of cement. Just to highlight.
Actually, earlier, our ancestors, they were using lime very commonly. But now people, they prefer cement because of its durability and other desirable qualities.
Okay, thank you, sir. What on
Thank you,
question?
sir. Thank you.
A very good afternoon to all of you. My special thanks to our speaker of this webinar, Dr. E.B. Perumal Pillai, Director HRDC, Welltech Rangarajan, Dr. Shagunthala R&D Institute of Science and Technology, Chennai, for his very interesting and thought-provoking address on innovations in civil engineering. Sir, knowledge which you have shared with all of us was very useful for all. Now, I would like to thank our Honorable Chairman Sir, Vice Chairman Sir, Director Sir, and Dean Sir for their permission to organize this webinar. I would also like to thank our convener and HOD, Dr. Arun Parwate Sir, for his continuous guidance and moral support to organize this webinar. Also, I thank our coordinators and faculty members for their cooperation. Once again, a big thank you to all of you. Have a pleasant day.
Thank you, sir.
Thank you, Professor. Thank you.
Thank you. Look forward to see you in Chennai soon.
Yes, sir. Thank you.
Thank you.